the requirement of being language agnostic serialization format like JSON and XML, which we heavily use. We also use something called Avro. We also use something called protobuf for distributed systems in large scale distributed systems. These are nothing but the serialization formats which we day to day use. And this is why I told how heavily these concepts are still being used in the industry. Next question, the most tricky question, and even I was asked about this in one of my interviews. Hi everyone, welcome to my channel Code with Ease by Varsha. So we have been doing a playlist on Core Java interview question and answers. So these are the questions which we have already covered. The most recent one is on multi-threading, concurrent hash map, and we've talked about wait, notify, and notify all. Today we will talk about serialization. Okay, so anything and everything related to serialization we'll try to cover as part of today's video. So let's begin. So we'll try to cover 10 serialization related interview question and answers. And so if you're a fresher, it is going to be like a foundation for you to start from scratch, to understand from scratch about serialization, as we have covered a lot of code snippets also. Secondly, if you're not a fresher, you're experienced, trust me, I'm having nearly 5 years of experience, and even today when I go to an interview, I'm still asked questions on serialization. And thirdly, it's not just about interviews anymore, it is also about the day-to-day backend coding that you are doing or you will be doing for developing, let's say, REST APIs on Spring framework, where you have to constantly come across your foundations on serialization and deserialization time and again. Every time these words, these jargons are going to be used. So if you don't know the intricacies of what is happening behind the scenes of how the serialization works, or what is the usage of the transient variable, the transient modifier. Like if you don't know these basics, it's going to be very difficult for you to write high-end distributed systems related code. So from that perspective, let's begin. Okay, so starting with the first question, what is serialization? It is the process in which you try to convert a Java object into a stream of bytes. What is a stream of bytes or byte stream? It's a Java input-output stream which has a flow of data where we can read. So basically, any Java object. What's a Java object? You write a class, you create an object out of it. You write the code for creating employee objects or your student object, anything that you write. So we create a Java object of that, and that object is eventually getting converted into a stream of bytes. So this process of converting into a stream of bytes is called serialization. Now, what do we do with this stream of bytes? Either we transmit or send this over a network, we save it in a file or in a database. This is what we do. Also, for security purpose, when we are trying to transmit the data, it is not secure to transmit your complex structured objects over network. So if you convert that into a stream of bytes, it's easier for the transmission because your communication protocols are designed in that way that they're able to handle your stream of bytes. So security is a concern. Easier transmission over the network is a concern. Also, you have several serialization formats which offer you language agnostic data exchange mode. What are those language agnostic frameworks? You have JSON. Be it your security, be it your ease of transmission over network, or be it for the requirement of being language agnostic serialization format like JSON and XML, which we heavily use. We also use something called Avro. We also use something called protobuf for distributed systems in large scale distributed systems. These are nothing but the serialization formats which we day to day use. And this is why I told how heavily these concepts are still being used in the industry. That is why the intricacies, the behind the scenes working is important to understand. Next is, after we serialize it and send it over the network or save it in a DB, what do we need? We also have to use the data. So we have to reconstruct it back from the bytes back to the object. That is the deserialization mechanism, where we deserialize the byte stream into the respective object. And static members of a class cannot be serialized. We will talk more about this. The next is a pictorial representation of how it happens. So you have an object which is getting serialized into a byte stream. Now, either that can be stored in files, it can be put into a network. Like put into a network, you have REST API calls, you hit the server, your client is getting the response. Now, then again, from here, it is reconstructing it back into the object, and that process is called deserialization. So I hope it is clear, first of all, what is serialization and what is deserialization. Object to byte stream, and again byte stream to object. Next is, how do you serialize an object? There are many different ways. Okay, nowadays we use common libraries like Jackson and JSON libraries. We'll talk about it towards the end of the video. But to start with, as a beginner, like when you're taught about serialization, you come across something called the serializable interface first. So we'll starting from scratch. So serializable interface is there. There's externalizable interface. So the basic is your serializable interface. Now, whenever you have to serialize a certain Java object, we have to use a serializable interface, which means whatever class is trying to have its objects being serialized, that class has to implement this java.io.serializable interface. So when you, okay, so another important point is about the marker interface. I've already made a video in detail about what is a marker interface. I'm going to link it up in the I button. So serializable interface is a marker interface. There is no method that you have to override in case of serializing. What it does is, it doesn't have any method, but it sends a signal to the compiler, to the JVM, that the object of this class, whoever is implementing me, the serializable interface, those objects have to be converted into a byte stream and stored it wherever it has to be stored. So there are two most important classes when we talk about serializable interface, that is object output stream, where it has the method to write the object, and object input stream for the deserialization. So there is serialization, there is deserialization. What is serialization? We do an output, we write the bytes into some file, into some DB. Deserialization is we take the input, we read. So output, write, input, read. So when we do deserialization, we take the input from whichever path it has the data, and we read that and we reconstruct our object. Serialization, you have the object, you convert it into a byte of streams, stream of bytes. Okay. So these are the two important classes. We'll see a code demo now. So you have a simple student class where you have two fields, the name and the roll number. Now what we are doing, we are trying to do the serialization. So into the main method. So over here, what we are doing, we have created a simple file into which we will write what? Our serialized object. So here we are trying to do our serialization over here. We are using the file output stream class. Okay, we are trying to call this method write object. And then we're just closing the connection and we are printing the object has been serialized. Basically, we are writing the details of John Doe, whose age is 25. This particular object of John Doe, we are saving into our student file. That's it. This is how we are storing in the file. This is the output you'll get, object has been serialized. Next is you want to deserialize it. You read it again from the file. So like I said, now we are going to use the file input stream class where we will try to read the object and reconstruct it back to our original class's object, which is the student class. And when we do that, we try to print out just to see if we got our original name of the student and the original roll number of the student. So this is how we deserialize. So only thing you have to understand, of course, you're not writing this code in real world application, but it's just that your mind should be clear. File output stream is for serializing it, you are outputting it. And when you're trying to deserialize, you're taking an input. Then you're using file input stream. Okay. And read object and the write object. So these are the two methods that we are going to use. So this is the output that you get when you deserialize. You're getting the name and the roll number back. Back from where? From the file in which you had written or saved your object. Next is how do we serialize and deserialize the object by implementing the externalizable interface. Okay, so serializable interface, commonly known, very commonly heard. Externalizable is a different interface. So when we use that, here we have to override two other methods. There we overridden write object and read object method. Here it is called write external and read external, respectively, for serializing and deserializing. Now, here is the code snippet. Same thing which we are doing. See, here also we are using this write external where we are trying to do the serialization, custom serialization. Why it is custom serialization? Over here, you can add some more additional logic. And of course, one more thing is you are supposed to override this method, which means externalizable is not a marker interface. Serializable, in case of serializable, you are not supposed to override the method. Okay, it was just giving an instruction to the JVM that it is going to serialize it. But for externalizable, when you implement it, you have the liberty of adding some custom logic while doing the serialization or the deserialization. So here we say write external, we are writing the object, we are saying out.write. So different bunch of methods are there. And read external, same, it will take in the input and where you can read the object, read the integer separately and do whatever business logic you have to do. So this is basically how it is happening when you use externalizable. Logic is the same. You have your student class, you try to serialize it, and then you try to deserialize it back. The actual logic is going to be the same. So the actual logic that you are doing is still the same. It's just that the different methods you are getting to override over here. So here we created a method called serialize object, and here we are trying to override the write external method, and over here we are trying to override the read external method. Okay. And this is the output, same thing. Now, the question is, what is the difference between these two? The difference is, firstly, serializable is a marker interface. Externalizable is not a marker interface. It has these two methods which are supposed to be overridden, which means you are supposed to add some logic to it. Default serialization process. So when you use serializable interface, we just implement this interface. We don't have to provide our own serialization logic. But over here, in case of externalizable, you have to provide your logic by overriding these two methods, the write external and the read external method. And custom serialization, like I said, for serializable, we can customize the default serialization process by defining these two methods, the read object and the write object method. Here, serialization completely customized. Like you have a choice to not customize also if you're using a serializable interface. But for externalizable, you have to override. You have to supply a custom implementation. Next question, the most tricky question, and even I was asked about this in one of my interviews. Okay, so I was asked about what is serial version UID and if I know what is it used for, what will happen if I don't use, and all of that. So let's talk about it. What is serial version UID and what is the impact of not defining it? So during serialization, every serializable class will get a version number, which is called the serial version UID. It is a 64-bit hash value which represents which version of the class it is. And it plays an important role in this entire process. What is the role? So this serial version UID, which is associated with each class that implements the serializable interface, remembers the version of the class. Why do we need to know the version of the class? So that we know that the program which is loading the object and the one which saved it, who is saving it? The program who is saving it. When we are doing serialization, then we are saving the state of the object. We are persisting the state of the object. The program loading the object as in when we are trying to deserialize it. So just to ensure if the versions are compatible, so the class file, the dot class file that has been created, just to ensure that dot class file has not been tampered with. Okay, that is possible, it's not getting corrupt or something. So the data which is there, it is in the right condition, it is preserved in the right condition. So to ensure that the class has, whoever has saved the state of the object, the same class is trying to deserialize the object. That is the intention of using this identifier to define the version of the class which is implementing the serializable interface. And to avoid the versioning issues and stable controlled serialization process, it's a good practice to explicitly define the serial version UID. Now, what happens if you don't define? So Java will automatically generate one for you. The only thing is, if it generates one for you and if you do it on your own, the only thing is Java will define it for you. That's not a problem. But what can happen is if they don't match, the deserialization process can throw invalid class exception. That is a serious problem. Although Java has generated it for you, you have not done anything with the class, but there are many factors it considers when it tries to generate it for you, when Java generates it for you. And if there is any other change in any other factor which you are not aware of, you during the deserialization you can get invalid class exception. So that is why a good practice is whenever you write a class whose objects you want to serialize, define your own serial version UID. So this is a small snippet of how we do it. We have this class which implements the serializable and we have a serial version UID. So this is the 64-bit hash value which we were talking of. Now, why are static members not serialized? This is something which we said in the first slide, that static members of a class are not going to be serialized. Why? Because they belong to the class and not to an object. Every time when we talk about serialization, we are talking about objects. Objects state being persisted, objects being transmitted over a network. But static members are what? They have a shared memory. All the instances are sharing that particular static member. So they belong to the class. So you have a constant defined and that constant is being used shared. That constant is being defined as static, private, static, final, and that is being shared across all the instances. Now, serialization will convert and store the state of an object. Now, static variables belong to the class and not the object, so they are not needed to be serialized. Serialization is happening per object. Every object state is being stored. And since a static member belongs to a class and not to a single object only, so we don't have to store the state of that static member, as simple as that. And if we try to access the value of a static variable, even after we deserialize, we'll get the default value of that data type. So we will not have any, we will not see any changes for that. So here we have a static field, which is value is defined as 10. It's an integer static field and we have a name. So when we create an object of this, so we see we have overridden the toString method so that when we try to print the object, we'll get the name and this is my static field. So I've named it as also static field. Now here, what we are trying to do is Same, like I'm trying to supply the name of the object. I mean, the name of the person is John Doe, and we are storing it. And we are then trying to do the same old logic of serializing and deserializing. Now, what happens is when you try to deserialize it, we get the name back. So the name only was persisted in the file. The static field's value is not serialized. Okay. But when we deserialize it, we get our data as is. There is no tampering with our static fields data. So even though it is not serialized, even though it is not converted into a stream of bytes and transmitted over network and all of that, but the value is preserved. The next question is, what is a transient variable and why do we need it? Transient variable, so transient is a special modifier. Just as you have access modifiers, you have transient, you have volatile, these are different modifiers that you have. It is a special type of variable whose values are not serialized during serialization and initialized by default. Okay, so now here it might confuse. You have transient. So please do not get confused between static and transient. Both are going to serve different purpose. Why static is not serialized? Because it is common to the class. You have a constant common to the class shared by all the instances. Transient is not the same as static because a transient field can belong to an object also. Let's say you have a password. Password is a sensitive information. You don't want to serialize it. You don't want to save it into any file. Of course, you can encrypt it, encode it, and then save it. That is a different logic. I'm saying I have a password. I don't want to transmit it over any network. So I will mark my password field as transient. I don't want to serialize it. Simple. So because I don't want to serialize it, so I'll mark it as transient. And because I marked that as transient, the entire object, out of that object, only one field of that object is marked as transient and that will not be serialized. I cannot mark that as static because password cannot be common for all the object. Every object will have its own password like any other field. So this is the major difference. The transients variable not getting serialized has a different reason of its own. It can be secure information, sensitive information, rarely used information, but static has its own reason. So when we have a field which is marked as transient, it is excluded from the serialization process and the value is not saved. The outcome of it is going to be still the same. And with the help of transient variable, we can prevent any object from being serialized. Okay. And we can mark the rarely used variables as transient so that it can help us in saving the time and space. So the major difference can be what is the difference of having a transient variable not getting serialized and the static variable not getting serialized. Even that can be a potential question that can come. So here we have a potential question, we have a name and we have a transient field. Now over here, if I show the output, the transient field is having 0. The default value, what was the type of this int? The default value of integer is 0. So that is what it is stored as 0. But it is not serialized. When we do a write object of this will not be serialized. Only when we deserialize, we get we reconstruct the object back, but we see that the value is the default value itself. The next question, can you make a subclass as not serializable if the superclass is serializable? Little confusing, trick question. So if the superclass is serializable, when a subclass will extend it by default, that will also become that will also be considered as serializable, but you can try to override it. I mean, you can try to avoid it. So how can you do it? Again, using the transient keyword. So if you have a subclass whose parent class was serializable and you don't want your subclass to be serializable, in that case, you can mark the fields of your subclass as transient. Another way would be you override these write object and the read object methods. Not override, you define it, because in case of serializable, we don't override any method. So we define these two methods explicitly, we define it and we make them through the not serializable exception. That is also any other way. So basically we're trying to do our custom serialization in this case where we don't want our subclass to be serializable. Next question is, can we customize the serialization process and can we override the default serialization? So we have already seen this. We can customize it when we define our write object and the read object method, like over here. Or we know that we can, instead of that, we can use externalizable. And here is how we can do it by using the serializable interface. And we are just trying to define our own logic in the read object and the write object methods. It is important to note that we have to define these two methods. So I'm saying again and again, serialize, don't get confused between the overriding and defining. Marker interface do not have any methods of its own. Serializable is a marker interface. So you're not supposed to override any method. It doesn't have any methods. What will you override? Externalizable is not a marker interface. There we override the methods. But in case of serializable, we define the own logic in the write object and the read object methods. let's wrap up with the final question for the day. That is, do we know any alternatives to serialization for Java application? This is more about the industry use cases. So Jackson library and JSON. JSON is something which I use mostly. So JSON and Jackson we use. These libraries are something which we use to do the serialization and deserialization, convert the Java to JSON format and JSON to Java. Again, like I said, when you're doing the APIs development, you have client server applications that you're developing, you will frequently have the need to do this interchange, Java object to JSON, because JSON is the most popular data exchange format, and again JSON to Java. So here is a small code snippet that we usually have. We have object mapper. So here we try to write the value as a string. Here we are doing the write the value. Again, remember, write serialization. We are writing the value as string, so we are doing the serialization. And how are we doing the deserializing? We are doing the read value. What we are passing over here as parameter, the class, the object to which class does it belong, that particular class we are passing for deserializing. Similarly, we have XML. It was used in the legacy applications also. JAX-B libraries are being used. This is a small code snippet. Personally, I'm not a big fan of using XML serialization. I'm more comfortable in using JSON serialization. Protocol buffers, also protobuf, which we call. It's developed by Google. It's also another alternative where we can use this protobuf library. It's also considered quite faster than the general REST APIs that we develop. Avro is another binary serialization alternative which is developed by Apache Hadoop. So I have worked on big data Hadoop projects. So I have used Avro over there, where I've stored or serialized data into Avro, and then also started to deserialize and read the data from Avro. So Avro and protocol buffer are more industry use cases, along with the Jackson libraries and the JSON libraries that you have. Okay. So yeah, that is all for today's video. Thank you so much for watching this. Please consider subscribing to the channel if you haven't already, and don't forget to like and share this video so that we get more motivation to bring more valuable content like this even in the future. So thank you so much for watching.